All right, let's find another antiderivative. This one is mostly about just using algebra to rewrite the initial problem. Again, I don't like mixing the decimals and the fractions, but that's just how it's given to us, so we're going to go with it. The first thing that you're going to want to recall is that the square root is the same thing as a 1/2 power. So we can rewrite the problem like this. Then if we remember our properties of exponents, we multiply these two exponents together to get x to the 7/2 power. We can then move that up to the numerator and make the power negative. All right, and I can't take it anymore. I'm going to call negative 4.59 This is going to be an easier function to take an antiderivative of. We can just use this formula up here. If we want the antiderivative of x to the negative 7/2, we just need to add 1 to this exponent. Adding 1 to negative 7/2 is negative 5/2, and then we're going to divide by that negative 5/2. Of course, we have a negative 9/2 as our coefficient here, so we're going to put a negative 9/2 on that, and we're going to throw that negative 9/2 up in our numerator here. So our antiderivative looks like this. We get a coefficient of negative 9/2, which we are dividing by negative 5/2, multiplying all of that by x to the negative 5/2 power, and we're going to add a c on there. Now the rest is just a little bit of simplification. If you divide these fractions, you just get a 9/5, and we are finished, except it's probably a good idea to check our answer. If we take a derivative of this function, we should get back to our original problem. Let's see, taking a derivative would mean multiply by negative 5/2, reduce the power by 1. The derivative of a constant is just 0. And when we simplify here, we get a negative 9/2 x to the negative 7/2. And if you reverse the algebra that we did at the beginning of the problem, you will get right back to where we started here. So it looks like we did everything correctly. And our final answer is right here.